In this video, we're going to be doing part 1 of section 1.6, Irrational Numbers Simplifying Radicals. So the learning target is to be able to express entire radicals as mixed radicals and to express mixed radicals as entire radicals. Our toolkit is understanding radicals, which we learned in section 1.3, and identifying factors of a number, so doing our factor trees. Some definitions. You have some numbers that are perfect squares, meaning that if you took the square root of that number, you would get a whole number as a solution. So if you take the square root of 4, you have 2, a whole number, as the answer. Perfect cubes, when you take the cube of that number, you get a whole number. So for example, 8, if you take the cube root of 8, you get 2. So some terminology, the difference between an entire radical and a mixed radical. So an entire radical, you have root 28 is an entire radical. So a radical sign with a number under it. Remember, this is called a radical sign, and then we have a number 28. This first one, the index is empty, so it means that an empty index represents an index of 2. Another example would be, we have an index with a 3 in it, 64. So here we're doing the cube root of 64. The index is 3 and our number underneath is 64. So this is an entire radical. There's nothing here on the outside of the radical. There's nothing in front. Okay? The 3 is the index, it's part of the radical. And there's nothing else. So a mixed radical is a number written as a product of a number and a radical. So a mixed radical has a number in front, then the radical sign, and then another number under the radical sign. Okay? So this means 3 times the square root of 5. You don't need to write the times, it's implied here. So 3 root 5. 3 times square root of 5. Another example, here's a 4. Then we have our radical with the 3, and then our 10. So just being aware here that this 3 is the index of this radical. It is not part of this 4. It's not saying 4 to the power of 3, okay? It's a 4 multiplied to the cube root of 10. So those are mixed radicals. You have a number out front, then you have your radical sign with whatever the index is going to be, and you have a number under the radical sign. So the next thing we need to look at is equivalent forms. Okay. To be able to work with radicals, you just need to understand, so this is kind of like background information, you need to understand that this is the same as saying this. So it doesn't matter if you put both things under one radical sign. So root of 16 times 9 is the same as root of 16 multiplied by root 9. So let's see how those are the same. If we took 16 and we multiplied it by 9, we would get 144. If we then took the square root of 144, it would give us the answer of 12. Whereas, if we did the square root of 16, that's 4, and we did the square root of 9, that's 3, and then we multiplied 4 times 3, it would give us 12. So notice that the final answers are the same, okay? So, mathematically speaking, you can write this like this, or you can write this like this. It means the same thing. And that's going to be important later. This also works regardless of what the index is. It could be a 3 in your index. It could be 4, 5, 6. It doesn't matter as long as the index here is the same as the index on each of the separate numbers. So let's take a look at why again. So we're going to multiply 8 and 27 together, and we still have our root. So 8 and 27 is 216. And when you do the cube root of 216, you get an answer of 6. Well, if we were going to do that separately, if we did the cube root of 8, we would get 2. If we did the cube root of 27, we would get 3. If we multiply 2 and 3 together, we would get 6. So our final answers, again, are identical. And we can write this down as a mathematical rule. So this is saying anytime you have two numbers under a radical sign, A and B, so the letters A and B represent any numbers. So for example, 16 and 19. So in this case, 16 would be your A, 19 would be your B. Or it could be the 8 and the 27. So 8 would be your A and 27 would be your B, whatever the two numbers are. So any two numbers under a radical sign are the same as if you split those numbers up and gave them each their own radical sign, as long as the n, the index, is the same for all of them, okay? We can use this property to simplify square roots and cube roots that are not perfect cubes, but have factors that are perfect squares or perfect cubes. So we're going to use this on the next page. So this is just background information to show you why what we're going to do next works, okay? So now we have two different radicals. We want to find the product. So we just learned that to be able to find the product, we could take one large radical sign and put both of our numbers underneath it, like this. And then we're going to multiply them together, and we get the root 18 as our final answer for this one. So here, I just rewrote my two numbers under one big radical sign, and then I multiplied them together. 2 times 9 gives me 18. Whoops. I'm going to do the same thing over here. So I can multiply these all together. I double check to make sure that they all have the same index. So here it's empty, empty, empty. So that means the index is 2 in all cases. So I can make a big radical sign. And I write 2 times 3 times 7 underneath it. And then I go ahead and multiply 2 times 3 times 7, put that in my calculator, and I get the answer of 42. Oh, I need red. Okay. So you can now try this out. You're going to go to page 52, and you're going to do question number 1, only the left-hand side. So you only need to do the left column, okay? And then when you finish that, you're going to move on to part 2, video part 2.